Nice, unique question here. We've got a quadrilateral. Four angles reach two-digit numbers. So AB is actually a two-digit number, and they can be placed. I think this is a bit misleading actually. They can be placed in a 2 by 2 grid with one digit in each cell, and find the possibilities for the set of all four angles. Um, so basically, we just need to find A, B, C, and D, all the different possibilities. I wouldn't get too focused on that grid. Now, we've got them in place value form. Actually, what we want to do to start with is put them in powers of 10 form. This is quite a good this is something to be aware of in math sometimes. It's just a lot easier to deal with. So 37, for example, is 3 times 10 plus 7, which means that AB is actually going to be 10A plus B. And if we write it like that, then we can start forming equations and trying to solve them. So in powers of 10 form, we're going to get 10A plus B, that's my AB, plus 10A plus C, plus 10C plus D, plus, and I've just realized I've run out of space, plus 10B plus D is going to equal 360 because this is a quadrilateral. Hey, and I've got an equation with four unknowns, but remember these unknowns are all integers first of all, but they have to be digits between 1 and 9 or 0 and 9. I suppose D could in theory be 0. So 0 to 9 basically. A or 0, sorry, not A. A, B, C, D equals 0, 1 up to 9. Okay, so we're going to be able to find these possible solutions. This is essentially a Diophantine equation. I'm not sure what I'm saying. Essentially, it is precisely that. Okay, so I've got 20. I'm going to simplify 20A plus 11B plus 11C plus 2D is going to equal 360. Quite awkward. Now, what a good strategy for dealing with these questions, I don't think the answers do this, but I'm going to do it here, is to look for a common factor between some of the terms. And there aren't really many. There's nothing that goes into all of them to start with. And 11 doesn't go into 360, but three of them are even. So I'm actually going to divide through by 2. Now, at the same time, I'm going to factorize out the 11. So it's going to be 11 over 2 b plus c. Okay, because this is going to be the easiest then to deal with. And then I'm going to be adding d, and then I'm going to have 180. Now, the consequence of this is that because I'm dividing by 2 here, we must have b plus c is a multiple of 2. In order for us to get a whole number overall. Something else to be aware of is that A is probably going to be quite large. If A was 1, for example, then you would only have, like, because both of these start with A, you'd only get, at most 38 here. There's no way that you could then make it up to 360. You can't have these angles being so small. You don't have a three-digit angle, for example, to make up for it. So I'm going to actually start with A being as large as possible and then work my way down until we don't get any solutions. So I'm going to systematically do this. So A equals 9 is going to be my starting point. So then 11 over 2 times B plus C plus D will have to equal 90 because 10 times 9 is 19. I then subtracted it. So what if b plus c is the largest possible multiple of 2 that we can have? If they're both 9, b plus c is going to be 18. Then I'd get 90. Wait, what would I get? 18, so I get 99 plus d equals 90. And there's going to be no solution to this because d can't actually equal minus 9. Okay, but at least we'll work on our way through it. So let's go with the next smallest, 16. And this is still in the frame that A is 9, by the way. So now I'm going to get 88 plus D equals 90. So D will equal 2. And I think I found my first set of solutions. So A, B, C, D, and I'll put these in brackets, could equal 9. Now to get 16, I could either have 9, 7, and then 2, or I could have 9, and then 7, 9, 2. Or I could have 9, if they're both 8, 8, 2. And that's it for B plus C is 16. I've just made 16 in 3 different ways. Okay, we'll come back to that in a minute. Let's finally take a look at, I say finally because I know what's coming up. B plus C is 14. Then we're going to get 77 plus D equals 90. So no solution here either. And B plus C less than 14, we're going to get no solution as well. Right, so that is it. I'm going to actually put a box around these. That is it for A equals 9. Okay, let's take a look at A equals 8. So now I've got 80. I've got the same thing, but it's going to equal 100. So this time B plus C, it could equal 18 because I'm going to get 99 plus D is 100, but D is going to equal 1. So then I would get 8, 9, 9, 1. If B plus C is equal to 16, then I'd get 88 plus D is 100. No solutions to that. And there's no solutions for less than 16. Now, if A is less than 8, then there's going to be no solutions either. I don't know how much working to show here. In the real thing, I'd probably do 7 and show that it just wouldn't work because we only just about got a solution here for A equals 8 when B and C were both 9. There's no way we're going to be able to make it work for A is less than 8. So no solutions here as well. Just make sure you've got enough working to be convincing of that. Right, finally, and this is where I find it a bit confusing. I've sort of found all the different solutions for A, B, C, and D, but actually, now I've realized it, we're asked for the set of the 4 angles. So I should write these down as my final answers. Okay, so those are all my answers from above. Just got to carefully put them in now. So we've got, as one set, we've got A was 9, so 89. And then 89 for top right, and then C would be 91, and then we get another 91. Okay, there we go, there's one solution. And then I've got 9972, so 99, 97, 72, and 92. That would also work, yes. Now, if I do 9792, then all I'm doing is swapping B and C around. And if you put that in, you'll see that you get exactly the same solution. So this is something I actually missed when I did the question, and I didn't want to just implement it like it was obvious at the start. But if you can spot it, you can see that B and C essentially like if you swap these two around, like the B and the C, you still get the same angles and the same over here. So it's almost like we can assume that B is greater than C right from the start without loss of generality. You won't lose any solutions, which would mean that you would eliminate this solution here. Otherwise, you just get an extra one, which we need to eliminate later on. It's okay. And then finally, we've got 9882. So 98, 98. Oh, wait, is that right? I think so. And then 82 and another 82. Yeah, that's it. All right, so this question, really nice, actually, I think, has 3 solutions. You just got to carefully get all of them, explain your methods along the way, show that there are no more, essentially, work systematically, and it comes out nicely. Brilliant.